Okay, so we're going to do a quick review before we get started on properties of logs. So we're going to look at what we were talking about yesterday. So convert from exponential to logarithmic form, 8 to the power of b equals a. So this would be log base 8 of a equals b. And this says convert from logarithmic to exponential form. So this should say y to the power of negative 8 equals x. Now simplify. So these are our properties. 2 to the power of log base 2 of x. Well, that's just going to be x. Log base 4 of 16 to the power of x. So I can rewrite this as log base 4 of 4 to the power of 2x, because 16 is 4 squared. And now log base 4 of 4 to the power of 2x. Well, using our properties, that's just going to be 2x. Same thing here. I can rewrite this. Log base 5 of 5 cubed, 5 to the power of 3x because we have our x. And now from our properties, you know that this is just 3x. Okay, here's a solve. So these have the same base. We're going to add the exponents. So 4 to the power of negative 2x plus x equals 64. And I can rewrite 64 as 4 to the power of 3. So this becomes 4 to the power of negative x equals 4 to the power of 3. So I have the same base. I set my exponents equal. Divide by negative 1 and x equals 3. So there's your warm-up. Now logs of logarithms. So what we're going to be doing here is expanding and condensing. So if I'm multiplying, what I can do is I can break it into 2 logs with addition in between. If I'm dividing, I can break it into 2 logs with the same base with subtraction. And if I have an exponent, that exponent is allowed to come out front as a coefficient of that term, k times log base b of m. We're not going to prove why these are true, but if you're curious, you can come ask. So we're going to be condensing and expanding. So let's start looking at the expanding ones. So expand all logarithms until each logarithm contains one term raised to the first power. So I'm going to be using my properties. Well, first property I notice is that this 4 is allowed to come out front. So I'm going to rewrite this as 4 log base 2 of m times n. Now I know that when I'm multiplying inside the parentheses, I can expand that into 2 logs using addition. So this is 4 times log base 2 of m plus 4 times log base 2 of n. Notice I kept the 4 as a coefficient with both of them. So this is, each logarithm contains one term raised to the first power. So here's my one term raised to the first power. Here's my one term raised to the first power. So this is my final answer here. Okay, one term raised to the first power. That's how you know you're done. All right, here, this is a cube root. So I'm going to start out by simplifying. This is going to be log base 2 of m to the 2/3 times n to the 2/3. Oops, times n to the 1/3, I'm sorry. Okay, so that's an exponent of 2, root 3. Exponent of 1, root 3. So that's how that's what that becomes. Now, I'm going to break these up because this is multiplication. So this becomes log base 2 of m to the 2/3 plus log base 2 of n to the 1/3. Now, I can pull my exponent out front. So this is now 2/3 times log base 2 of m plus 1/3 times log base 2 of n. There we go, and that's it. So I have each log has one term raised to the first power. My coefficients are up front. Okay, last one down here. Log base 2 of m to the 4th over n cubed. So now I'm dividing, so I know that I can split this up using subtraction. So this is log base 2 of m to the 4th minus log base 2 of n cubed. And now my exponent can come out front, so log base 2 of m minus 3 log base 2 of n. And this will be your final answer. All right, now we're expanding these, and it's the same thing until each logarithm contains one term raised to the first power. So this is multiplication, so I can expand it using addition. This becomes log base 2 of m to the 6th plus log base 2 of n cubed. And now my exponents can come out front. So final answer is 6 log base 2 of m plus 3 log base 2 of n. And that's your final. Alright, this one. This is a square root. Square root's the same thing as power of 1/2. So I can rewrite this as log base 2 of m to the 1/2 over n to the 3/2. Okay, power 3 root 2, power 1 root 2. Now I'm dividing, so I can expand it using subtraction. So this becomes log base 2 of m to the 1/2 minus log base 2 of n to the 3/2. My coefficients can come out front, so this is 1/2 log base 2 of m minus 3/2 log base 2 of n. And that's your final answer. Okay, now we're going to, let's try expanding this. So I'm going to pull these up to the numerator first, and I'm going to write this as log base 2 of m to the negative 1, n to the negative 1. Now this is multiplication, so I can split it up using subtraction. So log base 2 of m to the negative 1 minus log base 2 of n to the plus log base 2 of n to the negative 1. Use addition when you have multiplication. And bring my coefficients out, so this makes this negative log base 2 of m. And then when I pull the negative 1 out front, this becomes a minus log base 2 of n. And that's your final answer in that challenge one. All right, now we're going the opposite way, and we're going to condense. So you know you're done condensing when your coefficient is 1, and you have 1 log. So first rule here is that you have to have the same base. So we have log base 5 and log base 5, so we're allowed to use our properties. So I'm going to start out by saying this is log base 5 of m plus log base 5 of n to the power of 1/4. I'm bringing this exponent up top. Now I have addition, so I can combine them using multiplication. So this is log base 5 of m times n to the 1/4. And that's it. And all of this is inside that log. Okay, I'm going to bring the 4 up here, so this becomes log a to the 4th, and your base is 10 here, remember. And this is minus log b to the 1/2, your base is 10. Now subtraction means that I combine them using division. So this is log a to the 1/2 divided by b to the 1/2. And I can simplify this even further by saying that this is log of the square root of a over b. Okay. Express as a single logarithm or expression. All right, so same thing. This becomes log base 4 of p to the 5th plus log base 4 of q. Now I'm using addition, so to combine them, it's multiplication, so p to the 5th times q. And all of this is inside that log. So here's your final answer. This one becomes log of x minus log of y to the 4th. Since it's subtraction, I can combine using division. So log x over y to the 4th. And that's that. Use laws of logs to evaluate each expression. So this becomes log base 3 of 6 squared minus log base 3 of 4. And that becomes log base 3 of, and 6 squared is 36, divided by 4, which gives you log log base 3 of 9. And I know that log base 3 of 9 just equals 2 because 3 squared is 9. So that equals 2. Here we have log base 4 of 40 divided by 5. Well, 40 divided by 5 is 8. And then I can think 4 to the power of what equals 8. So 4 to the power of x equals 8. Well, I can rewrite this. 4 becomes 2 squares. This is 2 to the power of 2x. 8 becomes 2 to the third. Now I can set my exponents equal. 2x equals 3, so x equals 3 over 2. And so this whole expression equals x, is x equals 3 over 2. Here, I have log base 4 of 3 over 48. And 3 over 48 is 1 over 16. And 4 to the power of what is 1 over 16? 4 to the power of negative 2. So that's your answer there. And that's it.